Alright, so here we have a musical toy consists of a wooden ball that rotates in a horizontal circle around its central axis. It says the mass of the ball is zero point 0.3 and it is supported by two wires. And it says determine the speed at which the tension in both wires is the same if the ball revolves at a constant speed. Alright, so quick disclaimer. I found this particular question online and it's through Pearson. It is a multiple choice question, but the answer I got doesn't match any of the answer choices that I saw. So hopefully you can keep up and let me know if I've made any errors. If I did, feel free to shoot me a comment. All right. So here, in order to solve this, it says determine the speed. This is a conical system revolving around a central axis, which is this blue rod here. All right, so I'm just going to go ahead and draw my free body diagram. Here's T1 pointing up and right. So T1y is pointing up. T1x is pointing to the right because it has to make this right triangle. And then T2, that is also pointing to the right and up. I'm just going to draw T2x down here, and then I'm going to draw T2y there. So I'm just going to make two right triangles here. I'm going to draw my f of g pointing downward. F of g here in this case is longer than T1y, only because since it is a horizontal plane, the sum of T1y and T2y must equal to f of g for this particular problem. So f of g is greater, so I'm just going to draw it just slightly longer. All right, here, because it is revolving in a circular plane, it's a conical system with two strings. Here, I'm just going to say centripetal force is composed of T1x plus T2x, because the diagram has the T1x pointing towards the axis, and then T2x is also pointing towards the axis. Okay, so T1x and T2x are both pointing inward towards the center of the circle. So therefore, f of c is the sum of those two vectors. All right, or vector components. Here I'm just going to break up f of c into mv squared over r. I don't know what the radius is yet, but what I can do is go ahead and substitute out T1x and T2x. So T1x here, the angle here is touching the horizontal axis for T1. That's given as 50 degrees. So T1x would just be cosine because it is the adjacent leg, and adjacent is cosine. However, if you look at T2x, T2x is actually the opposite leg because the angle given for the second string is actually touching the central axis itself, which is the vertical axis. So the angle here is touching the y-axis, and if it touches the y-axis, the opposite leg in this case would be sine. So you notice here why T1x and why both components are called x. T1 is cosine and T2 is actually sine because the angle reference touches the horizontal versus touching the vertical. Okay. All right. On that, I'm just gonna go ahead and factor out T. The problem says that the tension in both wires is the same. So therefore, even though I wrote T1 and T2, I'm just gonna go ahead and call T1 and T2 just T because it said so. So I can factor that out. So you notice here from the second and third line, the subscripts disappear because T1 and T2 is said to be the same. All right, other than that, I'm just going to factor out a T because both these terms have a T. So here, I highlight T because I don't know what T is and I don't know what R is. Ultimately, we're trying to find V, right? So we have two unknowns here. So I'm going to go ahead and set up the Y information in the vertical direction along the Y-axis. T1Y is pointing up, T2Y is also pointing up, and that must equal to the sum, or to the vector pointing down, which in this case is f of g, and the sum has to equal to 0 because it's a horizontal plane. All right, so here's T1y plus T2y. It must equal to f of g. And then here, I just broke out T1y and T2y. Likewise, if you look at the diagram correctly here in orange with all these orange circles, or excuse me, components, T1y is opposite of 50 degrees here, so it's going to be sine. And then T2y is the adjacent leg of this 50, so that's going to be cosine. All right, so hopefully keep it up and let me know if I made any errors here. T1y is T1 sine 50, and then T2y is T cosine of 50, because that's the diagram said so. And the right side, I just broke f of g up into m times g. And then here, I factored out a t again because it says T1 and T2 are the same, so I got rid of the subscript. I factored out a t, and then I replaced m with 0.3 because it said so, and then g here is 9.8. Okay, because that's just a magnitude. I've already taken care of the negative sign here for you by saying positive must equal to positive. All right, other than that, to solve for t, I need to get rid of sine 50 and cosine of 50 in parentheses, so I'm just going to divide both sides by this whole entire quantity in the parentheses. Therefore, I'm just going to say this 0.3 times 9.8 is 2.94, and then divided by the whole parentheses here. That goes on the bottom. So wherever t is over on the left side here on the x-axis, I'm just going to substitute with 2.94, and then sine of 50 plus cosine of 50. And then this cosine of 50 and sine of 50 gets carried down. So what I do is I just cancel these two terms out, because it's sine of 50 plus cosine of 50, which is the same as cosine 50 plus sine of 50. So these are two exact terms. So I'm going to cross that out. So what I'm going to do is carry the work down. So it'd be 0.3 v squared divided by r, which is equal to 2.94. But here I don't know what r is. Right? Again, I need to find v, and I don't know what r is. And the diagram tells you that the distance between the two pivots here, where the two strings are tied, is 2 meters. So I'm just going to use that information and crack apart or to find r. All right. So here, to get v by itself, or v squared by itself, I'm just going to go ahead and multiply both sides by r, and then divide both sides by 0.3. So all I need to do is find r, and then I can just square root that and find v. All right, so let's go ahead and find r. Yeah. All right, to find r, okay, keep up. So again, let me know if I made any errors here. I'm just going to call this length L1, and then I'm just going to call this right here L1x, and then this right here L1y. Okay, ultimately I'm just making a right triangle. And keep in mind that this angle here is 50 degrees. That's given. So watch my cursor. Therefore, this angle here is also 50 degrees from the hypotenuse to the L1x. It's also 50 degrees. Okay. All right, on that, I'm just going to go ahead and draw out L2. The length of L2 is here, and then L2x is right there, and then L2y is there. So here I have two right triangles that I need to play with. So I'm just going to make a couple of statements and hopefully not goof off here. L1x must equal to L2x because it's touching the same of central axis, the vertical axis here, to the ball. So the length here for L1x and L2x must be the same. So I made the statement L1x is L2x. Other than that, I can break it up. L1x is L cosine of 50. Once again, because if you want to, you can just do L1x up here, right, where my cursor is going back and forth, and that touches the horizontal axis, which is cosine. Or, like I said earlier, from the red hypotenuse down to L1x, that is also an angle of 50. So L1x would just be L1 cosine of 50. And then L2x, though, however, is going to be L2 sine of 50, because the angle for L2 is touching the vertical axis. So across from that would be sine. So here I have two unknowns here. I'm just going to go ahead and solve for one of these. I have just chosen to solve for L1 just because it's already on the left side. So to get L1 by itself, I'm just going to divide both sides by cosine of 50, which brings the cosine of 50 degrees down to the right side there. Okay, I have all that highlighted because what I do know is that if I take L2y, which is this green piece right here, watch my cursor, right? If I take that little green segment and I add it to 2 meters, which is the distance from this point to that point, I should get L1y, okay? So again, if you take this little piece, you add the rest of it, which is 2 meters, you should get the length of this L1y. So on the right side here, I said L1y is whatever L2y is, okay? So this little vertical segment for the second right triangle, plus the 2 meters that's given. Therefore, I'm just gonna go ahead and break it up. L1y here is just L1 sine of 50, okay? And then L2y is going to be L2 cosine of 50 plus 2. Okay, so once again, L2y is right here. It's cosine because it touches this particular angle, and this is the adjacent. All right, so here I have L1 highlighted because on the left side here, I know what L1 is. L1 is simply L2 sine of 50 divided by cosine of 50, so I'm going to substitute out L1. So I can say L1 is L2 sine of 50 cosine of 50. And then I carry down the sine of 50 there, and then the right side I just left the same. So you notice here, the only thing that's unknown is L2. So I'm just going to simplify some work here. So if you have your calculator, please help me out. Make sure you punch your stuff in case I goofed. Sine of 50 degrees divided by cosine of 50 is about 1.192, and that's L2 that gets carried down. And then sine of 50 degrees, it's about 0.766. And cosine of 50 degrees on this side is about 0.643. L2 gets carried down, and there's the 2, it got carried down as well. So I'm just going to multiply 1.192 times 0.766. I'll get 0.913 L2. L2 gets carried down because you're multiplying. And then on the right side, nothing has changed. So here I'm just going to combine like terms. So to get rid of this 0.643 L2, I'm just going to subtract it from both sides. So 0.913 minus 0.643 is 0.27, and that's L2 because that's your unknown. And then here to get L2 by itself, I'm just going to divide both sides by 0.27. So it'll be 2 divided by 0.27, which I got about 7.41. Well, now that I know L2, I can find what R is, right? R is just this either L1x or L2x because that's the radius of the conical system. So here I made a statement that says R is indeed L1x or L2x because L1x and L2x are the same, and they're the distance from the central axis to where the mass is. All right, so here, since I already solved for L2, I'm just going to use L2x instead of L1x, so it's up to you. Notice here, up here in my work, I just decided to solve for L1 and substitute out because L1 is already on the left side. You could just solve for L2 on the right side and then end up solving for L1, and if you end up solving for L1, then you would do L1, cosine of 50, okay? All right. Other than that, I'm just going to go ahead and solve for R. I'm just going to plug in L2. I just solved for L2, which is 7.41. And then 1 times that by sine of 50. And then R is going to come out to be about 5.68. So now I have what R is. I'm just going to carry this function from the previous slide. In the previous slide, I said V squared is equal to 2.9 times R. And then I don't know what R was, so I did all this to find R. The denominator is just 0.3, so we need to rewind the video. And other than that, I'm just going to simplify my work. 2.94 times 5.68 divided by 0.3 gave me about 55.66. But then to get V by itself, I need to square root that value, which I did here. So therefore, if you do that correctly, I got an answer of about 7.46 meters per second. Okay. However, here's the thing. On Pearson, at choice A, B, C, and D doesn't match what I got. C is the closest, but it's still a bit off. It says 6.7. I got 7.46. Okay. If you kept up the work, feel free to let me know in the comment if I goofed anywhere, and I'd be happy to redo my video. All right. Hopefully the coffee's kicking in. Stay nerdy. Don't be whack.